Yeah, my name is Usman Salim, and I am PhD student in Prague, and he is my professor from Prague. He came here in Pakistan, so I just give a small introduction to him. Professor Vladimir Kochi, his name, is a professor at the University of Chemistry and Technology, Prague, where he works at the Department of Sustainability and Product Ecology. He is a recognized expert in life cycle assessment, environmental footprinting, and sustainability management with extensive experience in applying life cycle based methods to industrial systems, products, and supply chain. Professor Kochi has more than 20 years of professional experience in environmental assessment, sustainability consulting, and applied research. He had led and contributed to numerous national and international projects uh, focused on decarbonization, circular economy, waste management, and critical raw materials. In addition to his academic work, he is the founder of LCA Studio, SRO, where he supports industry and public institutions in implementing LCA carbon footprinting, environmental product declaration, and sustainability reporting frameworks. So now I will invite Professor Kochi to please give the presentation. Thank you. Thank you.
Thank you very much, Usman, for your introduction. Yeah, thank you. Dear gentlemen, it's my pleasure to present here some kind of work, what we do at our department, at our company. And I would like to give you some introduction about the current trend in sustainability assessment. The sustainability is not only the will, what we would like to do, it's also some kind of analytical approach how to manage not only our lives, but also our industrial needs, our industrial production. Of course, some kind of agriculture is a very substantial part of the sustainability. What I would like today discuss is explain something about the life cycle assessment, what is quite a new analytical approach, how to assess some interactions between human needs and the environment in general terms. And contrary to usually understanding analysis, namely in chemical context, the chemical usually do some in deep analytical as lower detection limits as better, as specific substance as better. So usually, I know I do it in short, but usually the chemistry is focusing on very specific details. Life cycle assessment is a very contrary, opposite approach. It wants to analyze as wide as possible consequences of our industrial operations. So LCA is a bit different. It's in context of chemistry, it uses the chemistry background, definitely, but it's much closer working with the process engineering and trying to integrate the environmental consequences in broad spectrum. I will follow this in more details. Later, I would like to introduce something about the GHG protocol, Greenhouse Gases Protocol, is now in the business starting to be a very important indicator, namely for financing of the industrial new developments. So the financial houses, namely in USA, Canada, and starting in Europe also, they are looking for the GHG protocol of companies, of organizations. So I would like to explain you what is the difference between LCA approach, which is focusing on products, and greenhouse gases assessment, what is focusing on the organizations. So it's a bit different scope of the work. Finally, we will discuss what is the EPD and PEF. This is some environmental product declarations, some documents which are now rising to be used in the business communication. And this is very important for us, for environmentalists, because without some connection of our goals to save the nature, without the connections to the business, we are short to do the realization in practice. My previous work, when I did my PhD 25 years ago, I was focusing on water pollution. I did ecotoxicology testing in my laboratory, so I was focusing on environmental protection. But I have seen at the time there was not too much interest in industry, in business, or in the governmental area about the environmental protection. Why? Because the environment was not a part of the business. So I know sometimes it's strange that we want to save the nature and make this a part of business, but probably this is the only tool how to realize this, how to make this happen. So this is the reason why now it could be a good chance to do, because the environmental product declaration and product environmental footprints, these documents are starting to be a part of B2B communications, but also sometimes substantial needs for the new investments. So hopefully we will go closer to some practical environmental protection in our business. And all this I cover today in some automotive supply chain perspective, because automotive is something what all of us knows. And we in our department and also at our company work quite often for the automotive companies. We have in Czech Republic the Škoda production. Maybe you know it's one of the best-selling car now in Europe. It is a part of a German Volkswagen group. So Škoda is very, very close to us, and we do several studies for them, namely in the chemical context of plastic production, recycling of plastic, and also in metal production. Metal production is now starting to be very interesting in the context of sustainability, because the metal consumers, I mean the companies buying the metals, steel, aluminum, they are starting to be very interesting in the context of the metals itself production, and they are looking for suppliers of the metal with lower environmental impact. Now, who can produce the metal with a better environmental context can ask for a better price. So this is something what we need, that a better environmental standard is a higher value on the business. And now it's starting to be, let's say, last 3 years. So it's quite new. And maybe this could be a good opportunity for you to integrate something of this into your work. So the current situation, namely in Europe, but I mean in the transatlantic context, so also the same situation is in the US, in Canada, and we also operate in Japan for Japanese companies. So it's possible to say it's a worldwide situation that now the companies are somehow looking for the ways how to integrate their achievement in environmental protection into the business. And what is more interesting, but it is not my speech too much about this today, is that it's not only the environmental impacts. The sustainability is always about the environment, but also about the society, about the human rights, if there is or not child work, equilibrium, if there is transparent communication, is there corruption or not? Everything this is the part of sustainability, which is quite interesting because it's more. It's not only the environment, but maybe you know from your day-to-day practice that if there is some high level of corruption, very often there is some high level of environmental pollution or some environmental impacts. So it goes hand by hand, not focusing only from the chemical point of view, only on the pollution, but we need also to be focusing on governance, how to do the thing, how to manage it. So this is for me very inspiring. And I have, me as chemist, I have a bit go farther than from my beginning when I was focusing mainly on the substances or living systems. I now need to understand the sustainability in much broader context. For example, I was a long time confused why it is not possible to change landfilling to incineration in our country. Why? Because of politician interests. Why it was not possible to integrate something, some better metal production? Because of geopolitics. So now, a lot of questions which what was not answered to me in the environment was answered by the geopolitics. So not only my YouTube, not only my pipettes, but also we need to understand these issues in much broader context. It's not easy, but it helps us as the chemists to apply our work into the much broader context. This is special. And this is also one of the benefits of life cycle assessment. It teaches us how to communicate those very specific chemical, environmental, biological answers to the broad auditorium. Because we need to be able to do it shortly, acceptable for everybody, for manager, economists, for politics. So this is also one part of the tasks of life cycle assessment to communicate the issues quite straightforward and with higher level of relevance. So, by the way, I will be talking mainly about the environment, but our general framework of our work is also the social and governance issues. Never forget about this. So now, at the beginning, I would like in couple of minutes express what is the life cycle assessment. It is quite a new analytical approach, what, looking for the answers, what are the consequences, we call this environmental aspects of any our activities. It's not only the specific industrial operation, but it is also the context of supply chain. So if you have a company, you are producing something, you need very often some inputs, for example, and electricity, some materials. And also the production of these supplying things is a part of your environmental aspects. So it's not only the direct aspect that you have a chimney with some emission. These are your direct aspects of an environment. But if you buy electricity and behind the electricity production, there is also some environmental impacts. So these aspects are also accounted to you. Because without this, you cannot operate. So this is the principal philosophy, that it's not only me and my direct emission, but also I need to know what is in context of my work. This is the first step to integrate this thinking into the business. We are starting to think about what will be better supplier for the metal, for the electricity. So you can ask your suppliers, what are your environmental consequences? If you are starting to think this way, you will probably in a short way be in a situation that you will also be contacted by your customers. If you want to sell your products to some company which is with higher sustainability, let's say, thinking, they will ask you about your own environmental aspect. So this is a domino effect. So you are somewhere in between. You will buy something, you will sell something, and in this broad context, you need to evaluate your environmental aspect. So it is quite interesting, and really last months, maybe 2-3 years, this is starting to be a part of the business. This is just to explain how we think in definition of life cycle assessment. And in the context of specific products like this presenter, like my garment, anything, any camera, any computer, everything has some life cycle. It is producing from some materials. These materials somewhere produce from crude, crude sources. And you start from very, very, for example, mining activities. You need to produce your materials, and then you can finally produce your very product. But this is not the end. If you sell the product to your customer, the customer very not all products, but majority of products will use it. And if you use, for example, the car, you need to fill it with the fuels. And also the operation itself has some environmental impacts because there are exhausts. If you buy a car with a lower or higher consumption of the fuel, you also influence the amount of emission. What does this mean? If you change from gasoline to diesel, you change from a combustion engine to the electric engine, for example, you can change the environmental impacts of the use. That means that you, as the user of the product, are also responsible about some part of the environmental impacts. So we call this the extension of the environmental context. So not only the production itself, but also the use of the products could be substantial for the environmental performance. This is also interesting that not only the producers of the product and you as a user are involved, but also the designers. They are much earlier, because if you design the product that it will, during the use phase, has a higher consumption of the fuel or lower, you are influencing the whole life cycle. So even the designers are a part. So forget the thinking that there is a company, industrial plant, they are responsible about everything. No, they are responsible about their part, but also the designers are responsible, also the investors for the activities, but also the users. We, in common man, if we use the car, for example, has some part of responsibility about the whole life cycle. This is not not all. The next steps after the users is usually end of life. The end of life could be disposal, landfilling, installation, but also recycling. Recycling is a part of the end of life, and if some product is developed that way that some part of the materials could be easily recycled, it's also part of design. Then you can diminish the final environmental impacts. It's also good to think at the beginning of the thing definition how it will be disposed. Because if you have finally some composites, for example, and packaging materials, juice or something like this, if you buy it in the composite packaging system, there is aluminum, plastic, paper, who knows what else, you cannot recycle it effectively. Of course, everything could be recycled, but with high contents of energy, high consumption of chemicals, and the final result will be of low value. So you also need to think about the final effect of the product. If the packaging, for example, will be of the single material, polyethylene, paper, aluminum, but single material, then it is easier to develop some system for the recycling. So this is quite interesting because in the food industry, they have specific needs, they have high quality requirements about the oxygen transport through the foil, etc. This is one aspect, but the second aspect is that we produce too much of packaging waste every day. You buy something, you drink a bit, then you have a trash. This is pity. In context of sustainability thinking, we should improve this. And also the life cycle assessment is framework, how to think in this context, how to integrate all these aspects into one single methodology approach. And that's why we are starting to be interested in this. So let's say 20 years ago, the life cycle assessment starting to be a very interesting scientific approach. And in the last years, it is starting to be a daily need analytical methodology for the business communication and for some governmental development. What is the definition? You know, what is the purpose of LCA? Yes. What is the next very important benefit of life cycle assessment is that beside of all life cycle of the product context that we talk, what I told you now, is that the life cycle assessment is not focusing on a single environmental problem. For example, the toxicity. We can assess from the life cycle perspective the amount of toxic emissions. But it is not all we need to know. We need to know also the impacts on climate change from the life cycle perspective. We need to know the life cycle perspective of ecotoxicity impacts. One part is human toxicity, another part is the ecotoxicity to the environment. We need to know impacts on the acidification of the environment, the ozone hole. So LCA always comes with the multiple environmental impacts. And this is a new step. At our faculty in Prague, we have also a department focusing on the water pollution. That's one department. The second department on air pollution. Another one on the toxicity in human food chain. All these colleagues are focusing on specific aspects, but it has such an image, right? But that's a reality. But they are not interested in the context, in all of it. Sometimes we do improvement in one part, let's say biofuels. Maybe you know the issue with biofuels. We try to reply to change some part of our fuel consumption using with biofuels. On the first side, you can think it's a benefit for the air pollution. Not always. If you just replace one part of emission with another part emission, for example, to soil, it's not the total improvement. It's just movement, the problem shifting from one area to another one. So one of the principal benefits of life cycle assessment is an identification of this problem shifting. If you want to produce a high amount of biofuels to save emission from the using of it, you have to know that the biofuel production, I mean the biofuels of the first generation, rapeseed, for example, or something like this, you need to have huge areas covered for the agriculture. If you have a monoculture of any plant, you need to protect them with some pesticides. So who will produce the pesticides? And there will be again some emission during the pesticides production. And also the pesticides in the countries, they are not harmless. They do some environmental impact. So maybe the result of using of biofuels will be lower emission of the fossil carbon, but it will be excess of environmental impacts in ecotoxicity. So you see, this is the move, this shift, problem shifting from one place to another one, not only locally or from a point of view of geography, but it's also from the point of view of the environmental impacts. So you improve the climate change, but you increase the toxicity. Is it good or not? And these questions are the principal questions for a life cycle assessment. It's good to think this way. By the way, if you want to produce the biofuels, you, beside of the pesticides, you use high amount of agricultural fertilizers. And these fertilizers, namely the synthetic ones, and we use, unfortunately, huge amount of synthetic of them, because for the huge production of biofuels, you need a huge amount of fertilizers. And these fertilizers are very often based on the fossil fuel consumption. Okay, carbon synthesis for the ammonium fertilizers consume a huge amount of energy. And where this energy came from? From fossil. So what was the benefit? We skipped from our car using from the diesel fossil. We are using biofuels in our cars, but we need the fossil for the production of the fertilizers. So it's just the problem shifting. Okay. Yeah. And this is the life cycle assessment. This is the LCA teach us how to think in this much broader context of our industrial, agriculture, and other activities. What is also a benefit is that in last year, the LCA is starting to have a standards how to do. So it's not only the scientific approach, it's starting to be also the methodology. What can be done based on some specific standard? International Standardization Organization offer this. So it's also now possibility to use these standards for some certification production. So you can develop some specific report about the LCA, and this report could be used for the business to business. So this is some much broader context of the life cycle assessment. And now I just want to mention that all the LCA is done in some specific system boundaries. These systems boundaries has to be defined. For example, in the biofuel example, if you exclude from the system, from the car use, the production of the biofuels without the production of the fertilizers, you skip something very substantial. So we need to define as broad system boundaries as possible, but of course in some reasonable scale. So that's why we have to define what is included and what is excluded. This is very principle for every life cycle study. And if you will try to compare different life cycle studies focusing on the same topic, you always have to check if they are the same system boundaries. We have a specific study subjects for our students at our university about life cycle assessment. One is for the bachelor, one is for Master of Science, of course, for the PhDs. And for the Master of Science students level, we always give them a project that they need to compare two different LCAs. And therefore, it's difficult. Yeah, it is, because they have to appoint what is the crucial point for to be comparable. So if you will check the internet, you probably find different LCA studies for one specific subject of the analysis, and the results could be different. This is not the problem of the LCA itself. It's a problem that you need to do it by the same way. I very often make some the image that's like the measurement of temperature. If you said, give me a temperature, what is temperature? You need to know in what technique it is different, is measured, in what scale, what are the units, everything has to be defined. It's common. If we do even very simple analysis, we need to have the rules. And if we have the rules, then it can be compared. You cannot compare the temperature in Fahrenheit and Celsius degrees. You need to have the same degrees. Then it is comparable. And it is not the problem of the temperature measurement. Well, this is the same with LCA. You need to have a specific rules, and then it can be comparable. But until now, it's not always used, because LCA is much complex compared to temperature measurement. So there is much wider aspects what has to be somehow defined. A very specific part of life cycle assessment is the functional unit. It's very nice to think in the context of functional unit because if you are focusing on specific product, then always the function of the product plays a role. For example, packaging of beverages. Imagine that you have water and you can pack it in plastic bottle or glass bottle or juice or anything, a soft drink you want to pack. What very often we have a question, what is more sustainable, the plastic packaging or the glass packaging? One and one bottle. The principle is not from what the material is, but what is the volume inside. Imagine that you have one glass bottle, let's say 1 liter, and one plastic bottle, 1.5 liter. Then you cannot compare one and one bottle because the function of it is to pack the water, and the function has to be equal for both systems. So we can say that I want to pack 3 liters of the water. This will be the functional unit, 3 liters of packed water. And consequence of this is that you need 3 glass bottles and 2 plastic bottles, because one is 1.5 liters. Yeah? And then you can compare. You can compare 3 glass bottles with 2 plastic bottles. This is the functional unit. So in LCA, we always need to have the same function of the product. In car, for example, it is not to have a car. If you buy a car, you want to drive it. So the function of the car is some, let's say, 200,000 kilometers of the way. So the function of it will be car offering me the ability to travel for 200,000 kilometers. And then you can compare. Some car for this distance need higher amount of fuel, rather lower, higher amount of aluminum, steel, etc. So we always compare the products on the same function. And in LCA, we call this a functional unit. The plastic bottle is very simple, but totally working example. You cannot compare one and one bottle if both of them has a different volume, because we do it for ourselves. The function of the product is a crucial point. And this is a very substantial second step of life cycle assessment, giving us another angle how to understand the environmental impact. We do not understand it only in the whole life cycle perspective from production to disposal, but we always express the environmental impacts in context with the function unit. Then it gives us a possibility to compare the results. And then you can look for a product with some better environmental impact. This is just to show that it's quite a complex work. When we start in the material production, a lot of operation takes place. Then we do the production of the product itself. We have to use it, and we have to count with the disposal or end of life. And that's why we call it in LCA always end of life, EOL, because it's not always disposal. It could be recycled, it could be reused, it depends on kind of product. So that's why we call it this way. And always the life cycle perspective count with all of this operation, and it is the most time-consuming part of the LCA because you need to collect data from all these processes. So that's why the LCA is something what we love in our department, because you have to be somehow expert in very broad spectrum of industrial activity. You need to know something about the energy production, material production, metals, plastics, etc. You need to know a lot about the machine construction, but also you need to know how the people use the product. this is very substantial and very nice. I like it. It's not only technological analysis, you need also know something of the sociological. Imagine the car. Our engineers at our department, our faculty, we also have the crude oil department, and they are doing a long time research about comparing, for example, gasoline and diesel cars. And they say that the diesel car has a bit better emission, let's say 5%. And they do it in very sophisticated machines and compare the emission. Imagine that you are driving the car. What will be the principal difference if you are having a leg on the gas or not? So the mean how you use the product could be much substantial in compared to the technology itself. Yeah. From the sociological point of view, more important is how do you use the car? How do you if you drive somehow environmental friendly, if you use if you are gentle in the driving, but if you use only gas and brake, you consume much higher amount of the gasoline, and there are high amount of emission. What does this mean? Of course, it's important to know the technology, how the engine is working, but without knowledge, how the man used the product itself could be false. You know? So it's also very special thing of way of thinking about the product. And end of life, we already discussed that it should be somehow producing in that way that it could be easily placed or used. Imagine, for example, electronics. We very often buy electronics for single use. You have a new cell phone, up to 2 years, you throw it away and buy a new one. Why? Because it's not easy to exchange the battery or improve the processor or something like this. This is the question of design. If the designers will define the product that way that it's easy to open and replace some part and to upgrade it to the new one, it's not possible to do it. So the design plays a crucial role. Design is a beginning before you ever start to work with your materials. So it's, the idea itself define, let's say, 80% of a future environmental impact. So it's very crucial to work with the designers too. And this is also one part of our work. We are chemists, but we know that the designers needs our output. So I also teach at the Faculty of Architecture, where we have a Department of Industrial Design. And I'm no designer, but I'm very happy to cooperate with designers because they are creative people. It's very inspiring for me. But they know nothing about the chemistry, nothing about the environment, so it's a good interaction. But their work without contact with us, chemists, could be very problematic for the environment. So this marriage, I think, could be very perspective in the future. So even the designers are a part of the environmental protection, even if they do not know it yet. But we have to show them how can improve this situation. Of course, the life cycle is not so straightforward like it was in the previous picture. It's very often somehow in circles. So the methodology of calculation is more complex, and we use some specific life cycle assessment softwares. Currently now you can download from the internet a number of softwares, and even OpenLCA is free of charge. You can download it quite easily. Start to have some experience with this. What is of the high value is the data. You need to know the data about all this operation, and it takes some time when you collect this, or you can buy it. There exist several data providers for life cycle assessment, but it's very expensive. So yeah, but that's the reality. because it's a lot of work behind the data collection. So I fully understand. We pay every year a huge amount of money for this data. Even we have a lot of our own data, but we need to have some additional information. For example, if you want to do LCA for Pakistan, you need to know what is the emission behind the electricity production. So that you need to have a data. Otherwise, you have to go to the energy company and ask for some data, and you spend half a year with this. So that's just the business of the country. Another very important topic in life cycle assessment is so-called allocation. Allocation is a situation when you produce two or more products during a single operation. Imagine raffinery. You have raffinery, and from raffinery you can get number of different plastic products or crude oil products. And everything what is before the production, we call it upstream. That means what was you need to mine, you need to produce something before, and later you have the pure products. And everything in upstream also has some environmental impacts. For example, during the crude oil production, you have some emission. And this emission has to be split somehow in between these two products. Because there are some consequences. We explained that the life cycle perspective is right, but we need to know that how to distinguish what part of this emission is for steering or for property, for example. It's not easy. There are a book written just about the allocation. So it's just good to know that there are some rules. The best for chemists is that we use so-called mass allocation. If we know that we produce some kilos of styrene, some kilos of propylene, for me, it's the easiest way how to understand this common allocation. But it's not always possible. Sometimes we have, for example, two very different products. If you have coal-based electricity, beside of electricity, you produce also a steam. And the steam is also sold because you can heat with the steam or use it for any other purpose. So if you have here the electricity and the steam, you cannot compare it by the way, because electricity, you can compare it maybe based on the energy. So you can do the energy allocation, but the question is again, what energy content in steam has to be accounted? Because the steam also depends on the pressure and temperature. So sometimes it's not very easy to find the proper allocation rule. But what is very specific, namely in the coal-based electricity production, is that beside of electricity steam, you also have some wastes based on some ash, and this ash is used as a recycling material in construction industry. So, and this ash contains zero energy. And so there is really a problem for allocation sometimes. Depends on the industrial plan. So now there is no time to explain all about the allocation, but it's good to know that something like this exists, and the LCA has to count with it, the allocation principle. The allocation principle also takes place during recycling. Recycling today is a very important activity because, for example, in plastic, we have a huge amount of plastic waste everywhere. And the only way how to help with this is to look for some recycling facilities and some recycling technologies, how to implement. In LCA, we have two different kinds of recycling. So-called closed loop, that means during the industrial activities, you have some bad products and you can use it again in your production. You melt them down and use it as a source of money. This is quite simple, but more complicated allocation is if you have, for example, that PET bottle for the water, and you can, from the waste of this material, use some plastic for egg packaging, for example, or any other product. And again, you have to solve the problem of the allocation because some operations are common for both these products, but some operations can allocate only to a single product. So this is the open loop recycling, and it is also a question how to calculate this. But there are some rules how to do it. And short, very specific question in the recycling of plastic is that every operation, when you do the recycling, every operation consumes electricity, some chemicals, produce some waste. That means that the recycling itself is not environmental friendly. We very often hear it in our context. Recycling is sustainable. Any recycling is sustainable only in the case that the product of the recycling will be reasonably used. But it is not always the truth. Sometimes we do the recycling technology and we find that the recycling product is not of such a good quality we want, and we dispose it. I know this from a lot of examples. Well, the plastic recycling, for example, is problematic because the product of recycling you very often cannot use in food grade packaging. This will be nice. Unfortunately, you cannot, because if you recycle plastic from the common mixed plastic container, for example, it's very often with some additives, with flame retardants, some small amount of chemicals, but final in the recycling material, you cannot use it in high standard. So in this context, we always say that recycling is good, but we need to know that every step in recycling increases the environmental impacts. We have to count with this. And it is reasonable if we find a good use for the product. A bit different situation is in the metals. In metals, it's quite simple in this way that if you have aluminum, steel, and you use it for one product, and then you remelt it or use it with some legend additives, you can have the product of almost the same quality that was at the beginning. That means using recycled metals to save the mining activities, for example. But in plastic, it's a bit different way. Now I'm a bit skeptic about the plastic recycling, and I understand it more like let's say, waste management level 2. It's better than disposing the plastic, but it's not very often economically reasonable. Because to produce the recycling material from waste plastic is very often much expensive in compared to the virgin material, because we have a lot of crude oil. Recycling is logical in a situation when you have or potentially lack of the virgin material. But this is not the case of plastic. If we somehow in future will close the fossil energy, we will have enough of crude oil for plastic production. Now we consume maybe 5 or 10% in plastic production. I don't know exactly the numbers, but for sure more than 90% of crude oil is just burnt. So we have enough if we will not burn it for the plastic production. And also we will have enough of crude oil for not single-use plastic. The plastic is perfect material. It's good to use it for a long time. The principal problem with plastic is that we use just a single one. In food packaging, in medicine, in hospitals for a lot of things. Yes, the plastic plays a very good role for us, but the production of waste is wrong. Let's move further. The life cycle assessment, impact assessment, is a point of the analysis when all the data about the emission somehow converge into the so-called impact category values or results. The impact category means the specific environmental issue what we want to somehow to manage. For example, carbon footprint means global warming, ozone hole, toxicity, acidification, excess of nutrients, we call it eutrophisation. So all these environmental impacts are by the same methodology expressed in LCA. So this is the life cycle impact assessment step. And then we get huge amount of data. We need to interpret it. We find some values. This is, for example, also abiotic depletion. I didn't mention it yet. One part of the impact category is also the resource consumption. We understand resource consumption also as an environmental aspect. It's very good to know if one or second product is more or less dependent on the materials. This is good for development. And we have a lot of methodologies how to express the life cycle impact assessment. In last time, environmental footprint methodology starting to be the principal one. And we also have some, this is European norms, some ISO guidelines for Europe. And we use again some spectrum of the environmental impacts. I show this table not because of you guys, but just to show you that it is not single value. It is climate change impact, ozone depletion, acidification, eutrophisation to marine environment, terrestrial environment, photo-oxygen ozone, smoke situation. So the LCA is always counting with some group of environmental impacts. And this is very, very beneficial for us because this is the prevention or the identification of problem shifting. Well, this can go, and finally we need somehow to interpret the life cycle assessment and the new information we call significant issues. This is a technical term in LCA. The significant issue is some output from the LCA. Well, one part of the LCA is the communication. You can communicate it different way by scientific paper, by a report of something. If you want to compare different products based on life cycle assessment, you need the same methodology for it. And this methodology is also published or is available, and it is called Environmental Product Declaration. It's this. Such a document is so-called third-party report of LCA, and it is short, let's say 10 pages only, and has focusing on the specific output of the LCA, what would be interesting for the business communication. So environmental product declaration is now to be found on the internet easily. It's a life cycle based description of a specific product. I know now the situation in Europe or US, China also. If you want to buy, for example, concrete from your supplier, you can, and if you have more than one supplier, you can select that one with as a product with a better environmental performance. So say, send me your EPD. You have one EPD, second EPD, compare the values and select the product which is better from the environmental perspective. And this is starting in the last 2-3 years in Europe to be the norm. That if you are, and that means that not only chemists or designers are involved, also people from economy of companies, because the sales managers are responsible about this. So we also do some courses for sales managers, for economists, businessmen, how to understand the environmental topics, and for the chemistry, it's not easy. Yeah. The principal thinking of LCA is that we should forget this old approach that there is some company producing pollution. Of course, it is. or some mining companies doing something wrong here on the disposal. We need to think in the life cycle perspective. That means we have to count all the emissions from all the processes, and we express it in context of the consumption itself. That means that 3 liters of packaged water or 200,000 kilometers of transport, something like that. This is the life cycle aspect. Now I'm almost done, so I have skipped some debate, but I skip this, and I want to explain you something that from this domino effect, that from every environmental or every industrial activities, we sum up the environmental impact. We can now go to the a bit different level of thinking on the level of the organization. Until now, I spoke about the product environmental context. Now, and it is starting to be very actual topic, is the what is so-called carbon footprint of the organization. It's very the organization focus is thinking about everything what is dealing with, let's say, 1 year of the operation of the organization. The same principle of thinking of life cycle, but it is applied to 1 year of the organization. Now, the carbon footprint, it's only one environmental impact. But let's focusing on one of these. Carbon footprint of organization is starting to be interesting value for the investors and also for the regulators. You can compare different organizations based on carbon footprint, and based on this value, give them better or more expensive money. I know the situation now that there are banks, investors, and if you do some, for example, development of new office building, a new office building could be with better or worse environmental impacts. And if you are able to declare, you as an investor, you are able to declare that the product will be with better sustainability standard, you can get better money for this, or you can sell it with our benefit. Now this is starting, it's working now in this. And I, in a couple of slides, explain what is the carbon footprint of the organization. It's a bit different methodology. The carbon footprint of organization is split in 3 different scopes. Scope 1 means the direct emission. Imagine you have a producing plant, plastic plant, for example. You have a chimney and there are some exhausts going into the air. This is your direct emission. You have, for example, natural gas engine, and all the emission you release into the environment are your direct emission. Into the direct emission, also all the vehicles are accounted. If you have some trucks or personal cars, and you consume some fuel and produce some emission, these are the direct emission of the cars. Some companies were thinking we will be sustainable and we will buy electric car. And they said we will have 0 emission. And you know the car Nissan Zero, not 0 emission. That only means that they shift the emission from the car itself into the energy plant producing. It's exactly the life cycle thinking. You move the emission somewhere else, but you communicate, we are clear, 0, Nissan. It's fun, it's greenwashing, in fact. And this way, a lot of companies were thinking, we buy electricity cars and we will be 0. Oh. The carbon footprint or carbon accounting system comes with this. So that's why we have scope 2. Scope 2 are so-called indirect emissions or emissions dealing with electricity consumption of the organization. So in the organization, by
any single kilowatt hour from the electricity supplier, all the emissions which were realized during the electricity production are also accounted to this organization. That means that you cannot lose your emission from electricity car use. You just have it in another bag. From scope 1, you have it in the scope 2. But it is there. This is very good because you can see that if you change your electricity supplier, you can change also your indirect emission. So if you have electric car, it could be very good in the case you have environmental friendly electricity, for example, from the solar system. So then it is different. But if and we do this analysis for companies in Europe, there was several companies that have bought for big money electricity cars. And finally, they decided when we did the analysis, we have higher carbon footprint. How is it possible? Because what electricity do you have? Carbon-based, coal-based, yes. That's the reason. So if you change the supplier of your electricity, your electric cars will improve. So this is the way of thinking. So indirect emission from the electricity, and it's not only electricity for the heating but also for the air conditioning in the case of the office houses. So this is very substantial. Very, very. Then we have so-called scope 3. Scope 3 in this range is all the materials you buy from your supplier. If you are building the house, you buy concrete, bricks, and anything else. All carbon footprint dealing with this supply is also part of your organization. So now you start to think, can I buy my concrete or my metal with some better environmental impact? Because if you can, then you will improve your organizational carbon footprint. Very good way how to improve. And also the second branch is what will happen when I put my product on the market and someone will be using it. In automotive industry, this is substantial because if you are a company producing cars and the cars will be used by someone, this is the reason why we produce the cars, that someone will be using them. And if in average every car will drive, let's say, 200,000 kilometers, it consumes huge amount of fuel and produces a high amount of emissions. That even these emissions are accounted to the product producing company. So that's the reason why the automotive company were starting to think about the effectivity of the engines in the cars. Because they realized that this impact are also their fault and they have to change it. How? They design some internal improvement of the product. So it is not about the chimney, it's also about the quality and design of the product. And finally, of course, the disposal of the product is accounted. And if you start to think in this context, here are some more detailed description of all parts of the scope 3 are accounted, but we don't have time to explain it in details. But what is principle that I skip this description of all the categories in scope 3. Time is passing so quickly. I want to show you one very principal result, what is quite typical for and apply. Yeah, this is this. We did carbon footprint of organization or number of organizations in Europe, and this is a plastic one. One company producing plastic. And now see what is the carbon footprint distribution in between 3 scopes. This is the scope 1, direct emission from the company. They're chimney. This is the scope 2, electricity supply. So if you change your electricity supply, you can move somehow with this. This is scope 3. And this is very typical for almost all companies producing something. If you are not energy producing company usually has higher the scope 1. But this is very typical for almost maybe 95% of companies. And what does this mean? If you want to improve your company carbon footprint, it has no sense to invest a lot into new technology. Because you can improve only 1.5%. But if you change your supply chain, you can do much better work in the carbon footprint without investment. Almost. So, and of course, if we do the detailed analysis of this, we can say this is the bricks, for example, this is the metals, this is aluminum, etc. And we do this analysis for automotive, for example. And in automotive industry, when they saw that the principal impact is their aluminum supplier, they ask their supplier of aluminum, what is carbon footprint of 1 ton of your aluminum? They start to count it, give them the results. This aluminum was, for example, from Dubai, with high carbon footprint. And it was one of the biggest wheel producing company, German company. They said, when we buy the aluminum from Turkey, what will be the carbon footprint? Then compare it. Or if we produce it from Italy or Islam, for example. And finally, they chosen that supplier of the aluminum which has the most carbon. What does this mean? This is the final context of my speech here. This means that it is not only good to improve your production because of the environment. This can support your business. Now, the environmental performance of your products will help to communicate to your customer that you are better some aspect than your competitors. This is the way how now in the sustainability thinking want to go further, because we feel this as the last opportunity to change something with the climate, for example, because only the regulation will not play a role. In Europe, we very often say, why we do this when US or China has huge emissions of carbon. But this will move them very fast into thinking. Now I know that even in China, they do very substantial improvement in this context, because they know that if they want to transfer, export some product into other parts of the world, they will face this issue. They will need to communicate that their product has some better environmental performance compared to the competitors. So this is in general the principle how the carbon footprinting is working. It's starting on the organizational level, but doesn't matter if you are a chemical plant, if you are plastic plant, if you are metal producer, or if you are developer company or anything, you will find that your supply chain is substantial. And in this context, you will need the product carbon. This is what we start with. The LCA of the product itself will start to be crucial analysis for the product export and transfer. And this is also in the short future the CBAM principle, the carbon footprint management of the borders between the states. Now it is only for some group of products which are very energy intensive, like cement, concrete, metals, fertilizers. But in the future, this we can expect will be more spectrum of products. So this is something what some of my colleagues, technologists, don't like. They say, we are the best technologists. We can improve our technology in emission. But I show them this. Yeah, imagine that your company will improve on a small amount. This do not mean that it's not reasonable to keep the environmental quality or the quality of the production itself, of course. But I just want to show that the much broader context of any company is also playing a substantial part. And without this, cannot achieve some improvement in the environment. Don't forget about the electric cars. This is the crucial example. If you use an electricity car, there is no zero emission. You just shift the emission to your supplier of the electricity. If you have a good supplier with good environmental performance, then also your car will have a better environmental aspect. But without doing the accounting with your supplier, you will never do this. And this is also the principal rule in sustainability management, as we did in our research application, that the sustainability is about the cooperation. You need to cooperate with your supplier and also with your customers. Thank you very much for listening. This was the end of my speech here. I hope you enjoy it as I enjoy the Pakistan stay here. Thank you very much for your
I have a question, but now I have nothing to say. There is a reality in the environmental community like the tragedy of farmers. Like the resources are not equally distributed among the people, like more society, like in Swat. The people are using their industry, they are using the water of the river and they are at that water. So the local people are affected from this, and the natural resources is only used by for the benefit of only individual companies. So how can sustainable development for this problem?
Thank you very much. It's a nice question. Besides the company footprint, also a topic is really actually in the science part is a water. The water footprint is also one part of life cycle assessment. And in a new methodology, there is a distinguish between the local of the water. So if you have steel from China or from Australia, it's still the steel. What's more, maybe the question is what energy is behind. Water is a different case. 1 liter of water in Pakistan, north or south, has different value. And if you compare it with Dubai, it will be extremely different. So we used in LCA for this so-called localization characterization approach. We distinguish the water from different regions. Again, for my colleague, the chemist, there is a water, one molecule, no difference. Yeah. But for our thinking is that it's not the molecule water, it's also the curriculum vitae of the course. It is the product. So it is the same like about the electric car. There is not only electric cars, there is also the electricity behind. So the same is this with the water. In LCA, there is distinguish the groundwater, surface water, water, of course, in case. And if you produce water from desalination system, how energy it's not water. And also in agriculture case, there is now developed so-called aware specific methodology to distinguish water scarcity index. And we can compare that 1 liter water from different regions used for different purpose and different environmental. So now there are developed some methodology how to count for the water consumption. And it is in the last methods, the groups of environmental impact, the water scarcity index is one specific impact category. So there are some progress. This is a really good point. For example, in Czech Republic, we are a small country in the middle of Europe. Germany, Poland, and Austria. Until now, we have quite enough water. But we are in the middle of Europe. It means we are not high mountains, but no river going into the Czech Republic. All rivers are going out. That means that we have only water from the bank, some groundwater. But until now, we do not have a lack of water. I hope before in the future, otherwise can be sure. But until now, there is no so strong scientific or industrial interest in the water economy. So, as I know, there is no specific research in this, but I think that in your country, this could be potentially really good research. The difference of the water, yeah, this could be.
If we look at the global warming, if we do the emission of carbon dioxide like carbon, so most of the emissions for right about 80 plus 80%, 80 plus emission is due to the America and China that developed and they are conflict and a lot of other people. So does these two countries contribute more to the global warming problem in the next decade or not?
Yes, definitely.
And I will add one more thing to that. Is there any policy in place to overcome this effect of the country?
I'm not governmental in this. It's more political issues. And you know, the last year with the Trump policy with that they told that doesn't exist climate change. We see it here. We know there is something happening. Of course, now it's very cold. It's very good, but this is also the product of climate change. That sometimes there are the extremes. But now the policy in the USA that it doesn't exist. We had said the government said there is no problem. It's horrible. But all the scientific communities are raised because there are thousands of evidence already to publish. Everything is clear. This is political. This is political. What in the context of her question could be optimistic is that based on this supply chain conflict, the Chinese see that this can play a substantial role because the market, for example, the European market, even if there is a much smaller part of the people, but the market is big and influence the rest. So they starting to change the way of production. Because, for example, that automotive company we are working for, Maxion. Maxion company is German company operating worldwide. They have production plants in every continent, maybe 30 countries, and they are producing the wheels for the cars. They told me that every 8 wheel award is from this company. It's really important company. We can say it's German company, but it's worldwide company. It's operating everywhere. And this, because I work for them, I know the situation. When they find homes that the carbon footprint of their aluminum and steel product is high, it doesn't matter if China, they skip, they want another supplier. And the Chinese were the first who lose their business. So they are now looking for another supplier, but of course the Chinese doesn't stop it around. They try to make it. This is maybe the effect, how this can be done even into this country. I don't know how it will be in the US. It's now with the president. Nothing can be predicted. Yeah. And you can think about the Chinese very wrong, but they are very pragmatic. They want a business, they want to develop. And if this rule starts to be the basement of the international trade, I am sure that they will achieve it. They will accept and they will work. So in this, I am a bit optimistic that Chinese could change something. And of course, because they have a specific regime, It's problematic for human rights, but it's very effective in the industry. When they say we want to do this, they do it. This is benefit. So hopefully, if they accept this, it will step of thinking will go very fast. And this is also crucial point for skeptical companies, because the green solution is now the best investment. It increase in the value of the business. And in future, probably only those companies which can operate come up with some better sustainability standard will have a better value market. So in this, I'm more optimistic in the case of China, but also in the US. I recommend, because there is not just the USA, certain states. But it's a very strong demand in California, which is very sustainable and driving into something in comparison to another part. So even if Trump say that it doesn't exist, climate change is why, because he's reliable to work. This is very easy. Even if you say that something, the industrial development or the direction of the industry in the USA is still evolving. The most expensive and the best database for life cycle assessment is now from the USA. As for the expert, we also work with this software. The software was developed in Germany, from my country, kilometers, very perfect German engineers was thinking about. And about 5 years ago, so they were more fine. So, hope, I don't know how the forest will be.
Maybe I ask you another presentation from you.
Yeah.
You mentioned in your presentation that part 2 is actual use of technology. So, for example, if we are making like ethanol biofuel and it can be produced from the fermentation of the fuel. Okay? So, the wood, is the food and the salvation in the world is very big problem. So, that looking like unethical.
Yeah. Short comments about the ethanol or similar fuels replacement. The LCA teach us don't think about the specific product, think about the service, the final goal. The final goal is the transport, the efficacy. If you want to save the emission, for example, here in Karachi, it is a trade. What will be the best way how to diminish the exhaust from the transport and the consumption of the fuel? If you will have a public, because more effective is if more people transport in one vehicle. And this is sometimes much easier and much reasonable. Why I'm thinking about this? Imagine that every one of us will have a car. And in future, more people will like or some standard or something. And if you will change the fuel from diesel to ethanol, for example, and if the number of people, the number of cars will increase, what do you will need? You will need more ethanol. If you want to produce it at industrial scale, you need the energy. If you will do it, depends on what source. I know in Brazil, from sugarcane, what is the result? They cut the first one sugarcanes, the forest. This is very important time. This is problem. So sometimes the replacement of one thing with another one, that's another consequence. The ethanol could be good for some part, but I feel it's a mixture of ethanol. But the problem will be always the quantity of the not the fuel itself. I often talk to my students the history. Why we started to use the crude oil in the 19th century? We wanted to save the layers. We wanted to save the production of the seeds for the production of the oil. We need more oil all the time. And in the time, more environmental friendly to use it. It was 200 years ago, and now, yes, it is so effective, increased. Now the power is the now. So, it is the same with the hydrogen-based fuels. We also have one plant for hydrogen in Czech Republic, but it's not so effective because there's different distribution. I'm more thankful that I know it's not 100%, there are a lot of problems with this, but sometimes it seems to me that the benefit of sugar-based in Brazil, they have sugar, they have mango. This is also one part that you can produce the ethanol with quite cheaply. But why? Because they pay the workers equally out of the world. Another sustainable problem. I don't have answers, and they are very complex issues. Just want to ask how we think about it. So it's not only about the technique, but also about the context. For me, the ethanol in Czech Republic is not very acceptable. We have one vegetable season, and we cannot produce the ethanol so cheap for this. We drink more than the cars. Yeah, but this is, we are more talking now about the hydrogen or the electricity. But maybe, I don't know how to hear the ethanol will be produced from rice, probably not. Yeah, I don't know. I expect it. We produce the ethanol from the fruits, so there is no sugar. We're going to, yeah. But imagine if the production of the sugar, how environmental intensive, we will need some fertilizer, we will need some pesticides, we will need some technique, land, drying, everything, like this. I cannot compare all this actually.
What about the sustainability of the electric cars and electricity as a replacement of what?
But you think what?
Sustainability of electric car or electricity in terms of carbon footprint and other environmental factors.
You know, the electricity is, this context is of course dependent on the source.
We use batteries.
The production of battery is also part for one month, 3 years scientific run comparing to vehicles on some sources of energy, also with the cars, of the batteries. And this is one of the examples of LC. You think that you have a car, electric car with less emission, but the production of the car is more intensive because you need a specific metals, which is really problematic to get some. But until now, what I have seen these studies, even with the counting of the car production, battery production, the final result is better for the electricity. It depends if your electricity system is robust, if you need a lot of investment, because it's limited, but generally it is potential because you can distribute the electricity to the areas. You also can use the cars. It is quite interesting from urban point of view system. We need to store the electricity somewhere. And the storage is not easy. We need a big something, battery problem. But our experts in urbanistic systems told us if we will have in every house good connection for the electricity, and if every cars will have an electric car, imagine that you use the car how many hours per day? Let's say 1.5 hours in the morning and the afternoon. And the rest of the day, if it will be connected to the electricity, the car, if we will have millions of cars, will serve us as a storage of energy. Because on the urban level, don't thinking in person, but if there will be understanding by the urbanistic system, then all our cars would help us as a society to store the energy. It is quite interesting because then you can use you can have in your car battery, and if you are at home, you can use this electricity, then not directly, but through the system, even for the light, for a computer. So it is the question how to solve the system, not only one specific product. In this context, it's interesting for you. Also, there exists cars with replacement of the batteries quite fast. Now we have it in Prague. There are food delivery companies who have small truck, and they are all operating in the car. And you smell it, it's better. Less emission, right? In the city, it's important. And you just, if you are empty in energy, you go to the work, they exchange you. It's fine. I have seen this also in Barcelona, in Spain. They have bikes like you have here, bike for electricity, and there are batteries. You can exchange it. You go to the place, just exchange, pay some amount to go there. It's fine. So even the use space of the electric transport, I don't have. But I'm still, I'm fine with this. I tried some electric cars, it was fine. It's very fast. Yeah. The driving ability, it's nice, so something beneficial, but depends on a lot of other aspects. What I have also read one life cycle study now in China, there's difference between European and Chinese electricity producers. The European cars, this car producers are thinking about the high level. They still have something special in cars. No? I don't think it's very, very good. The Chinese, they are not thinking about the car for normal men, not so expensive, maybe not so effective in driving. You know, the German drivers, they don't have strong cars, specific performance, etc. Yeah, on the one point it is nice, but common man needs a car to get to the job and home to do some shopping. You don't need some battery for 700 kilometers. Not necessarily. In average, I have read somewhere, in average, a man goes every day about 36 kilometers. If you go to your work, you can plug in, and if you go to home, you can plug in there. So you do not need some specific extra strong battery. And this is the way how the Chinese develop now new quite a cheap battery. I don't know if it's solar system. It's not so effective, but it's one of. And the last point about the electric transport I found out is that even I know the problem with the urban shipping, the electric cars will release the emission from the cities where the people are living. For me, this is the principle. Now, the majority of people in the world is living in urban systems. And we spend a lot of time here. And if we release, because for electromobility, all the emission, toxic emission of the particle dust and everything from the in-house from the cars outside of the city, it will improve the land loss. This is for me the very principal impact of the world. So this is another reason. Very often the people who are skeptic in electromobility told us it's the same carbon footprint like in diesel. It is, but I'm not focusing only on carbon footprint. In the LCA, there are also toxicity. And if a lot of people is living in cars or in streets. And if you release these emissions away, maybe to the plants, it will be beneficial for them. This is but maybe as a chemist, you know, that it's easier to manage higher amount or higher concentrations with it. So it's more effective, more cheap, and so for me, it will be better or easier to manage the huge amount of emission in one spot, on one chimney of big electric plant, comparing to billions of small examples. This is from the more life chemical point of view, again, the benefit for us.
So we have discussed so many things even beyond the topic of we have discussed so many things even beyond the scope of your presentation. I need a little comment on something that we see many various countries bomb each other, they bomb missiles on each other. The wars are in different parts of the world. So does this create environmental impact globally? Even though wars are in some parts of the world, it should be considerable now. The damage that they are creating.
And look how it
Environmental damage because of war.
I don't know that. You see, this is it's a really sensitive question. You are absolutely right that the war plays a huge environment. But it is so unfortunately, it's so extreme a situation. Unfortunately, it's not so extreme. But you know, I mean, for normal man, it's we do not want this in our country because you know you work with something what you can change. If you find that one time it doesn't in second, you can promote this to company producing and do some progress. But the war is always very strong discussion.
If the environmental producers or the scientists give the data to the government that because of your war, the humanity is being affected and this is the data. Like that.
I don't know. I don't know. Will be fine, but really, but
Those who don't agree will never get money, so we don't touch it.
yes.
There are two types of customers. One is higher income and especially in the US.
Yes.
Then goes to the product. One is Japanese product and Chinese product.
Mm-hmm.
Japanese product somehow decided you can put part some part of damage, you can recycle this product, but the Chinese product you can only once. So they also look to their customer, what their customers afford. So maybe the Chinese product have lower sustainable value than Japanese product, but their customer demand is high. How do you look at this? Like they should continue to produce this product at a lower sustainability. Then the Japanese product was higher number of customers look for the price of things better than price.
This is a special issue also. In every environmental studies, we found not only worldwide that if you use any product for a longer time, it's more sustainable, much better. The problem is the business model. But this is what this is not environmental. It's just it's business.
Talking about related to economics.
Yeah, this is the economy. Yeah. Sometimes it's they imagine, for example, the T-shirt. T-shirt, I have some my T-shirt for 20 years. But they're quality, they're working. No problem. But if you buy some bad Chinese T-shirt, you wash it once and disappear. This is problem. Environmentally, both the T-shirts are the same. The cotton production is the same. The production of the textile also the same. But the quality, yeah. So really, from this point of view, it's better to produce higher quality products for people willing to use them long time. This is the principle. Of course, if you are in society which is with lack of money, you want to buy as cheap as possible. This is the problem. But it has to be solved more complexly.
Was the development people mostly look into the price. They can buy it, they can like it easily. So the Chinese more looking into this like they have the same product, lower price. But when they have lower selling, but they once you can use it, then you should.
It's also a question of education to find out that price. Higher quality and use it for a long time. The behavior, this economical behavior is very specific to smartphone. I know it's presently, but I really know that it's good to know. Additional part, and also the life cycle costing. It's economic part of this to be again, it's super topic for research. We in Czech Republic, fortunately, we are not so. The society is almost unique. We are not very rich, we are not poor, but very same. Of course, there are some extremes, but generally we are only 10 million. Small country. So there was not to take to analyze the differences in the here. This could be a very important part to incorporate into the life cycle environment and also the status of the land. Because the solution could be different for different types of people. And it's good to know to work with this. Very important. I have a manager here. The manager is not thank you very much. We have 10 minutes meeting with the director. So thank you very much for your interest. I wish you all the best for beautiful country.